Hi, in this video we are going to talk about the stack data structure. As we have discussed in the theoretical section that we have the iterable interface, the collection interface, list extends the collection interface, and there are several implementations for the list interface such as array list, linked list, and vector. And basically the stack extends the vector class, so stack is a vector, stack is a list, stack is a collection, and stack is an iterable. Okay, so stack is a data structure. By the way, it is an abstract data type, but whatsoever, just to make it as simple as possible, it is a data structure where you add elements to the top of the stack and also remove items from the top again. So it has a so-called LIFO feature. The last item we have inserted is going to be the first item we take out. This is the last in first out, or the LIFO principle. Stacks are really good for some types of data processing. For instance, if you are parsing an XML file using either stacks or stacks. There are several methods when we are dealing with stacks: push, peek, and pop. The push method is going to push an object onto the top of the stack, so basically it is add an item to the stack. Then we have a peek. Peek method returns the object at the top of the stack without removing the given object, so it's not going to remove the object from the stack. And we have the pop method. The pop method is going to return the object at the top of the stack and removes the object from the stack. So that's the difference between peek and pop. All of these methods are going to return the last item we have inserted, but the peek is not going to remove that item, but pop on the other hand is going to remove that item from the stack. Why is it good to use stacks? What are the applications? If you are interested in graph-related algorithms, such as graph traversing, then depth-first search uses stacks in the background. Usually we implement depth-first search in a recursive manner, but in the background, under the hood, the operating system is going to use a stack data structure. And for example, if you are familiar with memory management, then the stack memory has a stack as an underlying data structure. So let's see some concrete example for the stack. We have to instantiate it in a generic manner. So it's going to be a stack that's going to store integers. It's going to be the stack. And I'm going to instantiate it as a java.util.stack. Okay, like this. And I think that we have to use this java.util for this stack because our class has the name stack as well. Okay, so the java.util.stack is the one we are looking for. Okay, so let's push some items onto the stack. So I would like to push, for example, 10. Then we are going to push the 20 and then the 30. Okay, and if we print out that what's going to be the stack.peek. What is this peek? It's going to return an object at the top of the stack. What's going to be the top of the stack? The last item we have inserted. This is the LIFO principle. The last in, first out. Last item we have inserted is the 30, is going to be the first item we take out. So if we run this method, it's going to return 30 because it is the last item we have inserted. If we, for example, call the pop method and then we call the stack.size method, the size is going to be 2. Okay, so we have managed to pop off the last item out of the stack, and that's why the size has decremented. If we call the peek method, then the size is not going to be changed. As you can see, we haven't removed the item from the stack. Okay, we are able to use the for each loop because stack is a collection. So integer I, as far as the stack is concerned, I would like to print out I basically. I save it. If we run it, we print out all the items of the stack. So this is how it works. we are able to push some items, we are able to pick some items, and we are able to pop some items out of the stack. And it has several applications, as I have mentioned, for example, graph algorithms with depth first search. Thanks for watching.